Yesterday, yeah, we are actually continuing the discussion. See, see, this is A. At A, and from A, I am taking a smaller distance. Okay, very smaller distance which is closer to A, which I am denoting or representing with delta. Delta is a very smaller value near to A, but this is not 0, not equal to 0. So the delta distance I am taking from A to the left hand side. I mean, delta units of distance I am taking from A to the left hand side. Delta units of a distance from A to right hand side. Okay, so this is the point. I mean, the distance from here to here is delta, and the distance from here to here is delta. Okay, right. So we already defined about delta and all. Okay, so on this delta, okay, for example, so this is already I explained. See, for example, the distance from here to here is, the distance from here to here is A, and the distance from here to here is A. Therefore, can you tell me what is the point over here? This is total distance is A, this distance is delta. Therefore, this distance will be total A minus delta will give what? This point, that is A minus delta. Once again, the distance from this y-axis to this place is A units. From A units, we have a small delta. So actually we wanted to find this point. I mean, what is the location, what is the value of this point? Okay, so that is A minus delta, and from here to here this point is what? See, up to here A, and this is extra delta space, therefore it is A plus delta space. Okay, so this is already done. If A minus delta, let us assume my values, for example, let's take some graph like this. Okay, at x this value is something, let's assume that is f of A minus delta. Next, at A plus delta, okay, actually it's not this large, but just for understanding sake I am taking this value. This value is A plus delta. Okay, let us assume this value is L1, this value is L2. Okay, now, and at A this value is something called L. At A the f of x value is L. See, we are taking a delta distance at this side, delta distance at this side. So therefore, even the space, okay, and this value is L. So even the space which is going to be created at this place is also going to be some constant value. This value and this value is going to be same. Okay, right? Because you are taking the same distance from here to here and from here to here. So automatically, this is where, I mean, this is also, I mean, here also it is going, I mean, L2, the distance from L to L2 is going to be same as the distance from L1 to L. For example, if this is 5 units, this is also going to be 5 units. It's going to come like that. Okay. So if you want, you can try some value. For example, here let's assume this is 5. Okay, this is something 4.9. Okay, at 4.9, whatever the value will give. Okay, let us assume it is giving some value. Now at 5.1, also it is going to give one value, but that is same distance from A. That is same distance from L. I'm sorry, L. So the distance from here to here and here to here same. So that constant distance, that small distance is represented with epsilon. So this is epsilon and this is also epsilon. Now, so here if you observe this epsilon, okay, this is actually, these things seems to be in graph, it seems to be little bigger, but they are very small. Okay, same as delta. Okay, even epsilon value is also greater than 0. Okay, these things we already discussed. Epsilon is also greater than 0, and it's a, but it is very small value. Okay, now see, let us assume what is the distance from here to here, L. Now can you tell me what is the distance from, this is total L, and the distance from here to here is epsilon. Can you tell me what is the point over here? Is it not L minus epsilon? Okay, just I just wanted to remove this. See, this total distance is L, and the distance from here to here is epsilon. Now what is this point over here? Is it not L minus epsilon? Now the distance from here to here is L and this is extra epsilon. Now what about the distance at here? I mean, what is the point at here? Is it not L plus epsilon? Okay, so L minus epsilon and L plus epsilon. Okay, so what is this epsilon? How you are getting this epsilon? Is it, can I say this is something like, okay, this value is L1, okay, this value is L1, okay, this value is L2. So L1 is nothing but, can I say L minus epsilon? This value is nothing but L minus epsilon. Can I say this value as L plus epsilon? No. Okay. Now what we can do is, what we can say is this epsilon. So can I say epsilon is equals to, okay, can I say epsilon is equals to L minus L1, the limit minus this value. Okay, epsilon I am transferring to this side, L1 I am transferring to this side. So L minus L1. Can I say this one as what? This is total L plus epsilon. From L plus epsilon, if you subtract L, won't you get this epsilon? Okay, see this total value is L plus epsilon and I am subtracting this L value. Won't you get this one? So therefore, can I say like this? Epsilon is equals to, I mean L2 is equals to, this is L2, right? From L2, if I subtract L, you will get what? You will get epsilon. Okay, this L plus epsilon only we are calling as L2, right? So L2 minus L, which gives epsilon. Okay, so this is the way we can define the epsilon. So what is epsilon? Okay, limit minus at the value at a minus delta and the function value at a minus delta, limit minus the function value at a plus delta. Okay, so that is epsilon. Now so this is how we can define the epsilon. Okay, so the distance from L minus epsilon, L minus L1 will give epsilon, and the distance from L plus epsilon, the distance from L plus epsilon minus L will give epsilon, or you can say L2 minus L will give epsilon, L minus L1 will give epsilon. For example, you can write as a modulus, because that is just a distance, right? Epsilon is the distance. So you can write L minus L2, L minus L2, or L2 minus L. Okay, right. Next, the other things, few other things we are going to discuss. Okay, now see, this is the epsilon itself is a very small value, but I am going to take some point at here. This place is near to A, but it is actually, see, look at this one, this is delta. I am taking the value at here. Don't you think this value is smaller than delta? See, delta value, delta distance is this much. From A, the delta distance is this much. Now I am taking even more closer value to delta, that I am taking here. Let us assume that point is x. That value is x. Now can you tell me, so x value I am taking, I mean x distance, I am taking x. X is how much? X, this distance is smaller than delta. Okay, I am taking x coordinate or x value, x units of distance. Okay, or I am taking one point. Okay, some standard distance, I am taking one point, and that point I am taking as x, and I am taking the same standard distance at right hand side, and that one I am taking as what? Okay, let us assume this is also x. Okay, so let us assume we are taking some distance. Okay, I'm sorry, from A we are taking even more smaller distance, that is at here, and in the equal units of distance I am taking one more point at here. Let us assume that point is x. Now what is the distance from here to here? Let's assume this point is x, so therefore the total distance is x, right? Now I wanted to find the distance from here to here. How to find it? So total is x, from here to here is x, and from here to here is x, and from here to A, that is A, right? So therefore, if I wanted to find this distance, is it not x minus a? So don't you think this small value is x minus a? Next, once again, so x minus a, even this distance also, I mean x minus a, it can be, now it is positive because x value is bigger here. For example, if I take here, this is a and this is x, for example, just imagine it is x, cannot be, but just imagine we are just taking a distance. Okay, now, okay, now we are taking the x distance, a distance. From a, if I subtract this x, won't you get this space? So that is a minus x. Okay, so a minus x and x minus a, if I place it in, I mean I just want to make everything positive, so to make it positive I am taking modulus of x minus a. Okay, x minus a will always give positive, a minus x means what? Okay, for example a minus x will give positive. Okay, so this is the reason why I am keeping under a modulus of x minus a. For example, if I write x minus a here, it will give negative value, so to avoid that negativity, okay, I am keeping the modulus. Okay, so this modulus, this small value, is it not greater than, see this space is actually visually it is clearly shows that, are clearly visible, like it is smaller than delta, right? So I can write modulus of x minus a is less than delta, yes or no? And but is it equals to 0? No, it is not equal to 0. Therefore, can I say this value, this small value, is it greater than 0? Yes. So we can write 0 is less than, because x minus a is greater than 0. X minus a is modulus of x minus a is greater than 0. So 0 is less than x minus a is less than delta. That's how the x minus a locates, or x minus a stays in the graph. Okay, so this is the relationship between 0, delta, a, x. Okay, so this is one more topic. Okay, see once again, this x minus a space is smaller than delta but greater than 0. That one thing, one point we have to understand. Okay, right. So this is the reason why we'll say this small space, it's almost, if you observe this is very closer to, I mean compared to delta, x is very closer to a, so therefore x is almost closer to a but not a. X is almost closer to a but not a. Okay, so this is about x, a, I mean x minus a and delta relationship. Okay, right.